SSCI, ABDC, and Scopus indexed journals. His experience lies in the area of data modeling, mediation, moderation, serial parallel relationship, higher order construct, reflective and formative analysis, marketing analysis, multivariate data analysis technique, data analytics, artificial intelligence, machine learning, and DL techniques. His research area are agri-tech, social media marketing, healthcare data analytics, and virtual marketing. I'm very happy to introduce you, sir. Thank you so much for being with us. I'm sure that you all will feel enriched with knowledge after completion of this event. I welcome you all once again to the workshop. Okay, I'm also glad to welcome our Dean, Dr. Manohar, sir, Associate Dean Selvam, sir, and other faculty members of VIT and outside VIT, student, research scholars for your present here. Okay, and I also welcome and appreciate Moshin Khan Jintu, Dr. Jintu, and the pillars of the grant program who are working behind the screen right from the inception with us, Deepalakshmi, then Asif and Kritika. I also extend my welcome to all the faculty members, research scholars, study for accepting an invitation and who are eagerly awaiting for this noteworthy session. Practice is the soul of knowledge. I hope our participant, they should practice the steps which you take French as and apply them their practice. So research scholars, I'm encouraging you all to actively participate in this event, and you can also, any questions, any doubts, you can clarify with Dr. Jasim sir. Okay, this is a unique chance to gain valuable knowledge and expand your networks. Thank you. Welcome you also.
Yes, participants, can you hear me? Yes.
Yes, sir.
Okay. Yes, let me continue. Okay. Couple of weeks before only Smart PLS introduced CBSIM interface. Okay. So unfortunately, I don't know who planned this workshop. They asked me to perform CBSIM using Smart PLS. Okay. As of now, we are using CBSIM using Amos. Whereas last two weeks back only, Smart PLS, they introduced new interface as a CBSIM in their software. So earlier, whenever we are performing CBSIM using Amos, we used to find lots of things. Okay, we used to find lots of difficulties in terms of model fit, in terms of AVE, composite reliability. In future, I will teach you. Let me give the introduction first. Then, and future, I will teach you what is AVE, model fit, composite reliability, discriminant validity. So it is quite difficult to perform those kind of analysis in the Amos. So Smart PLS, they created, they come up with one new idea. They introduced one new interface along with the PLSM. Okay, so it's a new interface. 2 weeks back only they introduced in the Smart PLS. Okay, so before starting my session, let us install the Smart PLS from the internet source. Then I will offer you Smart PLS code. All of you please install the Smart PLS. Then we'll proceed the today's session. Okay. So all of you, I'm putting Smart PLS website link in your WhatsApp group. All of you download that software. It may take 2 to 3 minutes. After that, I will send you the Smart PLS key. Okay. So let me share my screen. Okay.
So first all of you install that Smart PLS and he will be active only for 5 minutes. So better you complete this work.
Okay. So, okay. Then go to Smart PLS for download. Go to Google, type Smart PLS for download. Okay. Then I am putting that web link in your WhatsApp group. The web link already posted in your WhatsApp group. Is through that link, download the Smart PLS 4. If you are using Windows, please download Windows interface. Maybe some participants might be using MacBook. Please download Mac OS. Okay, I'm giving you a couple of minutes. Download Smart PLS from the website. Then after that, we will send you Smart PLS key. This key will activate for next 5 minutes. Since it is we got only 150 users. So after completion of the download, please inform to us. Then we'll share the Smart PLS key. So I'm giving you 3 minutes time. Unmute the external participants because we don't know whether they are installing the software or not. If they are finding any fault, they'll ask now. Yeah. External participant, those who are attending via online, if you have any doubt, please unmute yourself and ask. Any issues regarding installing of Smart PLS from the internet?
Sir, it's not downloading, sir. When I am
Yeah.
the link which you provided, I clicked on that,
Okay.
and then I'm trying to download. There's a download button in the top near purchase.
Okay.
Just
Okay.
adjacent to
Just
purchase.
see
I'm
my
trying
screen.
to.
Okay. Go to the
Okay.
website. Then
Okay.
you are finding one icon of Windows 64
Yes,
bit.
yes, it is there. Yes.
Just click this.
Okay,
Yeah,
fine.
see, like this, it will download. After
Okay,
that,
fine.
you install like a regular software.
Okay, okay.
Okay.
It's
Okay.
it's
Okay.
it's happening.
Sure.
It will
Sure.
take 3 minutes. Asking
Yeah.
3
Yeah.
minutes.
Fine. Fine. No problem.
Thank you.
Professional license.
I will give, madam, license. Okay.
Professional license.
Professional license will give. Wait. We'll give. We'll give. Yeah. Because we got only 150 users. If anybody is find any difficulty while installing the software, please inform to us. We are happy to help you. Maybe some other participants you might have installed earlier using the student version. If you are using the student versions, for them also will help you. Okay, let them install. Then I'll give you the instruction how to import the key in the Smart PLS. Okay. Yes, participants, now I am posting the Smart PLS key in your WhatsApp group. It will be there for next 5 minutes. Yes, after installing, please copy this key, then paste it in the given provision, then again install. Okay. If not, go to Smart PLS, then you will find two different menus. One is Smart PLS, another one is Files. Then click the Smart PLS, then switch license. Then start usage, then copy the license key. Smart PLS, then switch license, then again switch license, copy the new key, then paste it in the given provision, then activate the new key. Okay.
Jasim, you told the next step is professional first.
Yeah.
Absolute professional.
Select professional.
Sir, can you say
Yeah. Yes.
can you repeat that step? How to copy the key?
Yeah. In the WhatsApp group, we have shared the professional key. Then go to professional.
No, sir, mine is not downloading it. The network is too slow.
Okay. No problem. You wait. You download from the internet. We'll wait. No problem.
Somebody. Unmute. Unmute.
Sir, what we have to select? Choose your license type. Is it a student license or a professional license?
Professional license.
It's a professional one. Select professional.
Okay.
Should I remove?
Okay. Once done, please inform me because already 5:25. So we have to see lots of things.
Sir, it is done. It is showing that it expires in 71 days.
Maybe I will extend for extra 15 minutes or 30 minutes because for installation process it took 30 minutes. Maybe I'll take up to 7:50.
Sir, I put it the key and it's showing that it is valid for 71 days.
Is he asking anything?
Sir, when I'm pasting the key, it is telling that you can get the address. This is invalid server address. Please enter the server into the format.
Okay, choose the professional. Okay, choose the professional. Then, can you hear me?
Yeah, I can hear you. I have chosen the professional one. Connect to the license server, it is asking.
Yes, sir. I can hear you. Yes, sir. I can hear. Okay, so automatically it will work. This one is like for removing this.
Yeah, it's connecting now, sir.
Okay, fine. Can we start now?
It's connecting, sir. Yeah, it's connecting, sir. 1 minute.
Okay. Okay, if you try, meantime, let us start. So, related to data analysis technique. Under
Start
data
using.
analysis, yes.
Shall I click on the start usage?
Yeah, start usage.
Start usage.
Then
Okay.
choose professional license. Then copy the key from the WhatsApp group. Then paste it there. Then install.
You already
Sir, you
done,
try,
sir.
sir. Meantime, let me start because now time is 5:30.
Okay.
Okay, sure. Okay. Thank you.
Choose workspace asking. Sample project.
Sample project.
Yes. Choose
Okay,
workspace.
sure.
The window has come.
Okay.
Sir, excuse me.
Yeah.
Sir, we can get the workspace pin that is correct. You have reached the correct menu.
Yeah.
After installing, I can get the workspace that is correct.
Yes, correct. You are right.
Okay.
You are right. Okay, sir. Okay, let us start.
If you have any doubt, you please drop a message in WhatsApp group. We will solve it.
Sure.
Let's start. Okay, please.
Very good. Yeah.
Yes, I dropped.
You can have put like that. I'll take it.
Switch off camera also possible. Okay, na?
Okay. Are you able to see my screen? Okay. Yes. So, data analysis. Under data analysis, we have 3 different types of techniques. Under data analysis, we have 3 different types of techniques. One is univariate. Okay. For example, I have only one variable, single variable. That circumstances, we should go for univariate techniques. Under univariate, we have mean, mode, median. Then we can go for standard deviation. Then variance. Again, I repeat, mean, mode, median, standard deviation, variance, then normality like kurtosis, then skewness, kurtosis, skewness, then minimum, maximum, range. Okay. For example, I am having only one variable like age of the respondent. Okay. So I can apply mean. Through that, we can measure the average age group. Then median, standard deviation, variance, followed by kurtosis, skewness, minimum, maximum, range, then one way ANOVA. Okay. So under univariate, we have mean, mode, median, standard deviation, variance, kurtosis, skewness, minimum, maximum, range, then one way ANOVA. Okay. Then next data analysis technique, that is bivariate. Okay. Bivariate in the sense we should have minimum 2 variables. For example, I am comparing age of the respondents with satisfaction. Okay. So here I have 2 variables. One is age, number 2 satisfaction. If I want to measure 2 variables, we are supposed to go for bivariate techniques. Under bivariate, we have 2 different types. One is parametric, another one is non-parametric. Parametric, another one is non-parametric. Under parametric, we have 4 types of tests. Again, I repeat, under bivariate, we have 2 types. One is parametric, another one is non-parametric. Under parametric, we have 4 types of tests. One is t test, z test, t test, z test, then f test, then ANOVA, analysis of variance. Okay. Second, I repeat, under parametric test, we have 4 types. One is t test, z test, f test, and analysis of variance. Okay. Under t, again, we have three different types. One is one sample t test, one sample t test. So why we are teaching this without having the fundamental knowledge of data analysis techniques? It's very difficult to learn CBSEM and PLSM. Okay. Under t test, we have 3 types. One sample t test, then independent sample t test, one sample t test, independent sample t test, then paired sample t test. Under t test, we have 3 classifications. One is one sample t test, number 2 independent sample t test, number 3 paired sample t test. Okay. Under non-parametric we have chi-square test, run test, then rank sum test, chi-square, run test, RUN, run test, rank sum test, then sign test. Chi-square, run test, rank sum test, then sign test. Yes. If I am having more than 2 variables in my questionnaire, or maybe I am having more than 2 variables in my research model, proposed model. If you are having more than 2 variables, you should go for multivariate techniques. Multivariate techniques. So univariate for single variable, bivariate for 2 variables, multivariate for more than 2 variables. Okay. Then multivariate. Okay. So under multivariate, we have 2 types. One is dependent techniques, interdependent techniques. Dependent techniques, then interdependent techniques. Under multivariate, yes, we have 2 types. One is dependent techniques, another one is interdependent techniques. Yes, as I told you before, when to use multivariate? If you are having more than 2 variables. Exactly correct. It's more than 2 variables. Yes, for example, I am having one dependent variable, maybe student satisfaction as a dependent variable. Let me keep 2 independent variables. One is teaching quality. Number 2, curriculum. Okay. So I want to measure student satisfaction. I am keeping 2 independent variables. One is teaching quality, another one is curriculum. Okay. So if I want to check the relationship between teaching quality and student satisfaction, or if I want to measure the relationship between curriculum and student satisfaction, we supposed to go for dependent techniques. When you want to measure the relationship between dependent variable and independent variables, since here we are having more than 2 variables. So if you are measuring the relationship between dependent variable and the independent variables, you're supposed to go for dependent techniques. Okay, whereas I want to check the grouping or factoring or maybe something related to perception of a independent variables alone. Here independent variables we have teaching quality and curriculum. I am not comparing with the dependent variable. Okay, when you want to measure the independent variables alone, you're supposed to go for interdependent techniques. Okay, so under dependent we have multiple regression, then canonical correlation, multiple regression, canonical correlation. Then third one is MANOVA, multivariate analysis of variance. Again, I repeat, when you want to measure the relationship between dependent variable and independent variables, you should go for dependent technique. Under dependent, we have multiple regression, canonical correlation, then multivariate analysis of variance. Okay, then interdependent techniques. Here I want to check the grouping, perception, or maybe I want to divide the independent variables or independent items into different factors. Okay, so under interdependent technique, we have factor analysis, cluster analysis, multi-dimensional scaling, MDS, multi-dimensional scaling, conjoint analysis, factor analysis, cluster analysis, multi-dimensional scaling, conjoint analysis, neural networks, NN approach, neural networks. Again, I repeat, under interdependent techniques, factor analysis, cluster analysis, multi-dimensional scaling, conjoint analysis, neural networks. So if you want to check the relationship between dependent variable and independent variables, obviously we should go for dependent techniques. Whereas if I want to measure the relationship among the independent variables, we should go for interdependent techniques. Whereas we have one beautiful tool which you can measure or you can utilize that as a dependent techniques, also as a interdependent techniques. That is called it as SEM, structural equation modeling. Structural equation modeling. Okay, that's why people are speaking about SEM, because okay. So same thing I am maybe putting in the PPT also. Okay. So under multivariate methods, we have dependent methods, then interdependent methods. Okay. So as I told you before, you can consider structural equation modeling, either CBSEM, covariance based structural equation modeling, or partial least square structural equation modeling as a techniques you can perform, or you can consider that as a dependent techniques or dependent methods, also as a interdependent methods. Here you can measure the multiple relationships. You can measure the moderations, mediation, serial parallel mediation, moderation, then mediation moderation. Okay. Okay. So today we are going to see something related to CBSEM. Tomorrow I'll start the PLSM. So now only we are entering into the today's topic. As of now, we have seen what is data analysis. Now onwards only we are slowly entering into the structural equation modeling, CBSEM. Okay. So CBSEM. while doing the research, either will go for scale development or theoretical development. Either will go for scale development or theory development or theoretical building. Scale development or theoretical building. Okay, scale development maybe based on my topic, I will download minimum of 50 literatures or maximum 100 literatures. Out of 50 to 100 literatures, maybe I'll choose 50 variables, 50 items, or maybe 50 questions for my questionnaire. Then I'll go for, initially I used to go for face validity. I will circulate that questionnaire to the experts. Then based on their opinion, or either I will go for brainstorming or Delphi method. Brainstorming, I'll circulate the questionnaire to the group of individuals. I'll get their opinion. Whereas in the Delphi method, I will circulate the questionnaire to the group of experts. I'll get their opinion. Okay, based on their opinion, maybe I will add some of the variables, or else I will add some of the items. Again, I repeat, either I will add some of the questions, or either I will remove some of questions from the questionnaire. Then after that, again, I'll go for pilot. In the pilot study, maybe I will collect the data from 50 respondents. Then I'll perform reliability. That is Cronbach alpha. Then if reliability is adequate, then again in the second phase, again I will collect the data from 80 to 100 respondents. Then I will perform EFA, extracted factor analysis. This I think one more resource person he is going to discuss. Okay, so once EFA is confirmed, in the EFA, out of 50 questions, I am going to divide 50 questions into maybe 5 different factors. Each factor based on the correlation matrix, it will divide into different buckets. Okay, then based on the buckets, again I will create my own research model. Then again I will collect data from 100 to 150 respondents. Then I'll perform confirmatory factor analysis. So after conducting the face validity, then reliability analysis, extracted factor analysis, then confirmatory factor analysis. After that only, finally, we are fixing our scale. This is called it as scale development. Whereas theory building or theoretical development is totally different. For example, I am taking some variables from theory of planned behavior, like attitude, subjective norms, perceived behavioral control, then behavioral intention. Okay, those variables already available in the theory of planned behavior. Maybe I will add some local variable based on my research, or maybe I will take some available scales or existing scales from the paper, then I will add that as a one variable. Okay, so this is called as theory building or model building. Okay, for each construct like attitude, subjective norms, perceived behavioral control, then behavioral intention, I will adapt items from the existing papers or existing literatures. Okay, after that I'll go for pilot analysis. I will run Cronbach alpha. If I'm getting Cronbach alpha more than 0.7, then I'll go for final data collection. Then I will do measurement model and structural model. Okay, so there are two types. One is scale development, another one is theory building. Okay, whenever you are going for scale development, you're supposed to use PLSM. Whenever you are, again I repeat, whenever you are using scale development, you're supposed to go for PLSM. Okay, whenever you are adapting theory or maybe any available models, you should prefer covariance based structural equation modeling. But all my PhD scholars, they are having more interest towards performing PLSM, or else for all my analysis, I am using CBSM. Okay. Okay. Then very important aspect, difference between covariance based structural equation modeling and partial least squares structural equation modeling. Yes, if you want to perform CBSEM, you should have minimum 3 items or indicators under one construct. For example, I am having one construct as attitude. If I want to perform CBSEM, I should have minimum 3 items. Whereas PLSM, even one item is more than enough. Under attitude, you can keep one item. Then required sample size for CBSEM, large, whereas PLSM, small. Okay. So one of my paper, last year it got published under Emerald. The name of the journal is Benchmarking and International Journal. It is a ABDC B category journal. Okay, Scopus Q1. Okay. I'll open the paper. This paper is something related to, we measured the service quality of surgical instruments. Then we have collected the data from the medical practitioners. People, those who are having more than 10 years of experience in the United States. So we utilized snowball sampling. Through referral, we have collected the data. Since we kept only 112 as a sample size, even during the review process also, there are so many reviewers, they commented on our sample size. Okay. Then we mentioned in the review process, there are so many papers already published, which is having 50 as a sample size, 60 as a sample size, because this context is totally different. Because identifying the respondents is very, very difficult, because people should have more than 10 years of experience in the United States. So in that case, obviously, we supposed to perform only PLSM, not CBSEM. Clear? So if you want to perform CBSEM, you should have large sample size, or else for PLSM, small CLSM, small sample size, even you can keep 100. Okay. Then in the PLSM, you need to perform measurement model, then structural model. Measurement model, outer model, I'll teach you while we are discussing these things in the smart VLS. I'll teach you. Okay. Then structural model as a inner model. Whereas in the measurement model, you have to follow 3 different steps. One is confirmatory factor analysis, CFA, confirmatory factor analysis. Then second step, SEM with the CFA, SEM with the CFA. Then finally, spectral equation modeling, SEM. First step, step 1, CFA. Step 2, SEM with CFA. Then third step, structural equation modeling. Okay. So here in CBSEM, CFA and SEM with the CFA, we used to consider that as a measurement model. Whereas SEM, structural model. Structural model. Then fourth important difference, three steps. One is confirmatory factor analysis. Number 2, SEM with CFA. Then structural equation modeling. Step 1 and step 2 in the CBSEM, we used to consider that as a measurement model. Whereas step 3, normally we used to consider that as a structural model. Okay. Then fourth difference, goodness of fit. There are so many model fit indices are available for CBSEM. Whereas path analysis and structural model both are same in CBSEM. Okay. So goodness of fit measures, there are so many fit measures are available for SEM, CBSEM, whereas PLSM, there is no model fit. That's why people are afraid to perform CBSEM, because we have AGF5, GF5, NF5, goodness of fit index, RMSCA, RMSR, SMR. All the measures should be greater than the perquisite measures. That's why people are having afraid to perform CBSIM. Okay. Then final important difference. If you want to perform complex model in the CBSIM, quite difficult. Quite difficult. I am keeping 2 moderations, 3 mediations, 1 moderation mediation. You cannot able to perform using CBSIM. Quite difficult. Complexity. If you are having complex model, go for PLSM.
Excuse me, sir.
Yeah.
Could you please explain what are the different goodness of fit measures used in
Yeah, I'll
CBSM
come.
and
While
PLSM?
we are performing with the data,
Okay, okay.
we'll discuss how to measure RMSEA, what is the threshold limit, everything we'll discuss. Okay. Next is various packages to perform PLSM and CBSM. Normally PLSM, we used to prefer Smart PLS, then PLS graph, then VAR PLS. Even you can go for R programming using PLSM package, R programming using PLSM package, or Python programming using PLSPM library, or advanced analysis for composite. Whereas R and Python, open source program, rest of the platforms are GUI, graphical user interface. If you are having more proficiency towards writing coding, you can go either R programming or Python. Then CBSIM is Amos, Literal, M+. Again, in the R programming, we have one package, that is 11 package. Then in Python, SemoPy library. Then also we have some open source GUI, graphical user interface, that is Jamovi, JSP, JASP. 2 weeks back only, Smart PLS introduced CBSIM. So we have to add that in the list. Okay. Smart PLS. Through Smart PLS, even you can perform CBSIM. Okay, these are the various packages.
I hope you all have installed your software, Smart PLS software, and now our expert is going to demonstrate all the things in that software. If you have any problem or any doubt regarding this, you can please ask, or else we will start.
Fine.
Okay. Okay. After installing the Smart PLS, you will get this interface. Here you will find 5 different icons. One is new project, then PLSM, regression, process modeling, CBSEM. This is a new interface which is added by the Smart PLS for the benefit of performing CBSEM in the Smart PLS. Okay. So whenever you want to perform any model, hmm?
For what space? If not is selected one space.
Right. Yes, choose your workspace. Then it is like a folder. It will navigate whatever data you are having. Just to create one folder. Okay. Whenever you are giving any outputs or whenever you are downloading any reports, automatically it will store in your workspace. Okay. Then navigate your workspace. The meantime, I am uploading one data file in your WhatsApp group. All of you download the data file. Through the data file only, I am going to teach CBSEM. Okay. I have shared one CSV file. All of you download that file. Through that file only, I'm going to demonstrate CBSEM. So I'll perform CFA, then SEM with CFA, then third step, structural equation modeling, SEM. Okay. So after performing in the Smart PLS, then I will teach you how to write inference for each tables. Okay, I am having that source file also. I will teach you how to write inference for each tables as well as for the each pictures. So all of you download that data file from your WhatsApp group.
Yes, sir. Download it.
Okay, okay, fine. Okay, here we have two constructs. One is customer satisfaction, another one is customer loyalty. Here customer satisfaction, our independent variable, customer loyalty, our dependent variable. Okay, so under customer satisfaction, we have 3 items. Again, under customer loyalty, we have 5 items from CS1 to CS3, then CL1 to CL5. Okay, those items we have adapted from the some standard scales, okay, which already published. Okay, so it is something related to theory testing or theory development, or maybe I am having some existing proposed model. I am going to test the model. In that circumstances, we supposed to go for CBSEM, covariance based structural equation modeling. Okay, so here CFA, confirmatory factor analysis. CFA, I'll perform to measure the relationship between constructs and items. Okay, here construct is customer satisfaction. Under customer satisfaction, we have 3 items. Item 1, CS1, CS2, then CS3. Likewise, construct 2, customer loyalty. So under customer loyalty, we have 5 items, CL1 up to CL5. Okay, if you want to check the customer satisfaction, how far these 3 items are having association with the customer satisfaction. Likewise, how far these CL items are having relationship with the customer loyalty. Okay. Okay. No. Okay. Okay. So again, I repeat. So let me discard. Okay. So again, I repeat. Here I have one small basic model having two different factors. Yeah. 1 minute. Okay. Okay. Yeah. Are you able to see my screen?
Yes, sir.
Now? Now?
Earlier, sir, screen was visible. Now it is not visible. Now it is coming.
Okay. Fine. Okay. Thank you.
Now,
Okay. Here I have one small model having two factors. One is customer satisfaction. No, for them it is coming. Huh?
earlier it was coming. Now it is not showing.
Okay. Now? Okay. Thank you. Okay. So in my research model, I have two constructs. One is customer satisfaction. Number two, customer loyalty. Under customer satisfaction, I have three items: CS1, CS2, and CS3. Under customer loyalty, I have 5 items from CL1 to CL5. These items, as well as constructs, we have adapted from some of the published literatures or from some of the available scales. Okay. So here I want to measure the relationship between customer satisfaction and customer loyalty. Okay. Initially, I need to perform CFA, then SEM with CFA, finally structural equation modeling. First is confirmatory factor analysis. I want to check the level of relationship between these 3 items and customer satisfaction. Okay. This part alone. Then again, I need to check the relationship between customer loyalty and 5 different items. Okay. If we want to measure this relationship, we need to perform confirmatory factor analysis. Okay. Then again, step 2, I want to check both constructs as well as both the items like CS1 up to CS3, then CL1 up to CL5 for entire model, entire measurement model. This we used to call this as a structural equation modeling or SEM with CFA. Structural equation modeling with confirmatory factor analysis. First one is CFA. Number 2, SEM with CFA. Then third one is I want to measure the inner model relationship, hypothesis. Okay. Here my first variable is customer satisfaction. Second variable is customer loyalty. Here I want to measure the relationship between customer satisfaction and customer loyalty. Or else I want to measure the impact of customer satisfactions towards the customer loyalty. This call it as inner model. If you want to test the inner model, you need to perform structural equation modeling. Okay. So first step is CFA. Number 2, SEM with CFA. Third one is structural equation modeling. Okay. So again, in the inner model, our independent variable is customer satisfaction, whereas our dependent variable customer loyalty. Here I want to measure. You have to set the hypothesis like this: satisfaction has a positive effect on loyalty, or satisfaction has a positive impact on loyalty. Okay. So initially, we'll perform confirmatory factor analysis, then SEM with CFA, then structural equation modeling. So while performing CFA, SEM with CFA, then SEM, I will teach you how to write inference for each tables. Okay, so let me open the smart VLS. Okay, so after choosing the workspace, then you will find 5 different interfaces. One is new project, number 2 PLSM, number 3 regression, number 4 process model, number 5 new interface 2 weeks back only added by the smart VLS, that is CBSEM, covariance based structural vacation modeling. Okay, so I am going to use the same data which I shared in the WhatsApp group. Okay, please all of you download the data. Since the organizing committee member, they asked me to conduct this as a hands-on training. So all of you download that Excel file. Okay, so after that, go to new project, new project. Yes, if anybody is having any doubt, any point of time, you stop me. Okay, so go to new project, then type, I am giving name as first CBSEM, or maybe you keep your paper name, service quality, customer satisfaction, or customer loyalty.
New project is where it is increasing, sir.
New project, right corner. You are here. We are having 5 interfaces. No, here.
New project. Yes, correct.
Yeah, left corner. Yeah.
We have to name it.
Yeah. You have to name it. One CBSEM. Okay. Here, anybody having any doubt?
Shall we create, sir?
Yeah. 1 minute.
Sorry, it is not highlighting. The new project is not highlighting.
Left side.
No.
Corner it is highlighting. For workspace sheet, we have to choose.
Yeah. Wait. Let me share my screen.
Okay.
Yes, are you able to see my screen? Yeah. Now? Okay. So then go to new project, then give name as CBSEM. Okay, maybe you may keep your paper name or your research model name, or maybe. Okay, then after creating this, you will find 2 options. One is import data file, left corner in the list menu under the workspace. One CBSEM. Under that, you will find 2 options. One is import data file. Number 2, create model. Then again, after that, choose import data file. Then navigate your data. The data which I shared in your WhatsApp group. I am just navigating the data. Then after navigating the data, you will get this pop-up. Okay.
Yes, sir. Got it, sir.
Okay. Since I have given 7-point Likert scale for the questionnaire, so minimum value is 1, maximum value is 7. Maybe you may give 5-point Likert scale, or maybe 3-point Likert scale. Okay, I'll repeat once again. Okay, go to new project, then give the name of the folder. Then after that, you will get the folder under the workspace. Then under the folder, you will find 2 options. One is import data file, number 2, create model. Then click import data file, then navigate the data. The data which I shared in your WhatsApp group. Then select the data. Then you will get this pop-up. Here you will have the name of the items. Under customer satisfaction, we have 3 items. Under customer loyalty, we have 5 items.
Yes.
The minimum is 1, maximum is 7, because I have used 7-point Likert scale for my questionnaire.
Okay.
Then click import. Import. Yes, after importing the data, again you will get one pop-up. Here you can check the missing values. I think last 3 days you people are learning SPSS. Okay, so the SPSS also you can find missing value after the calculation. Whereas the smart VLS, While importing the data itself, you can identify the missing values. Then mean, median, then scale minimum, scale maximum. Even here you can check the normality, that is skewness and kurtosis. Skewness and kurtosis. Before performing structural equation modeling, you need to measure some of the assumptions. Okay, assumptions like normality, assumptions like normality, then communalities, communalities, then collinearity. Okay,
Sir,
I hope.
sir, in setting up scale, sir, we have to choose minimum and maximum.
Okay.
So the minimum is 1 and the maximum is 7.
Yeah, because since I utilize 7-point Likert scale.
Yeah, so we have to write 1 and 7 in the
No.
Okay.
No.
Okay.
That is only applicable for SPSS, not for smart VLS.
Okay.
Thank you. Okay, here we are getting skewness and kurtosis. Okay, the reliable threshold limit for kurtosis and skewness. Kurtosis should be -3 to +3. Yes, again I repeat, kurtosis should be +3 to -3 or -3 to +3. It should be the range between -3 to +3. Then again skewness always small. That's why it starts with S. Okay, so range should be -1 to +1. -1 to +1. If you are not getting adequate kurtosis and skewness for a particular item, you should remove that item from your questionnaire. Okay. Then after that, click back menu. Again, it will come to the first screen. Okay. So after importing the data, instead of importing more data, you will get your data, name of your data file. Here my data file name is basic model 1. Okay. Next is go to create model. Again, I repeat, after navigating your data or after importing the data into the smart VLS, then go to create model. Create model. In the create model, automatically project name will come. Our name of the project is 1CBSIM. Here, model type, we are going to perform covariance-based structural equation modeling, not PLSM. Here you need to choose CBSIM. Again, I repeat, in the model type, you should select CBSIM. Then model name, can we keep first CBSIM or CBSIM for basic.
Sir, can you hear me, sir?
Yeah. After importing the model, again go to create model. Then in the model type, choose CBSIM. Then model name, let me keep basic. Okay, then save. Again, I repeat. Okay, after opening your smart PLS, okay, you will find 5 interfaces. One is new project, PLSM. Third one is macros, regression, then CBSIM. There you select new project. Then you have to create the name of your folder. Then create the name. Then you will find 2 options. One is import data file. Another one is create model. Initially, you select import data file. Then navigate the data which I shared in your WhatsApp group. Then after that, then go to create model. Then folder name already we have given. Then select the model type as CBSIM because we are going to perform covariance based structural equation modeling. Okay. Then third one, you have to give the specific name for the model. So I am giving basic as a model name. Okay. Then you will get this screen like a MS Paint. Okay. Left side, number of indicators or number of items, customer satisfaction from 1 to 3, then customer loyalty from 1 to 5. Initially, I need to perform confirmatory factor analysis for each constructs, then followed by I will perform measurement model for entire model, like combination of customer satisfaction and customer loyalty. Then finally, I will check the hypothesis, relationship between customer satisfaction and customer loyalty. Okay, so let us perform confirmatory factor analysis for customer satisfaction. Okay, then you first select CS1, first item belongs to customer satisfaction. Customer satisfaction. Then again, then select CS2, CS3. Okay. Again, I repeat, keep your cursor top of the CS1, then press Shift and Control, then down arrow. Okay. Again, I repeat,
Sir,
select CS1. Yeah.
Still, sir, we are. I'm not getting the screen what you have. I have the different screen. That is basic model screen. Then we have to go back again and.
No. The screen you are having now. Am I correct? You are having the screen.
Yeah, this screen is visible, but I am unable to see this screen
Okay.
after the first. Can you repeat? Once again?
Okay. Go to new project. Okay. Create the project name. Then create. After that, you will find two options. One is import data file. Another one is create model. Then the import data file, import the file which I shared in your WhatsApp group.
Yeah, that I did.
Okay. Then go to create model. You will have one pop-up there. In the model type, choose CBSIM. In the model type, select CBSIM. Okay. Then you have to give the name for the model. Okay. Can I proceed further?
Okay, sir.
Okay. Thank you. Okay. Then you will get the second screen like a MS Paint. In the left side, you used to find the number of items under each construct. Here we have two constructs. One is customer satisfaction. Another one is customer loyalty. Under customer satisfaction, we have 3 items. Under customer loyalty, 5 items. Initially, I want to perform confirmatory factor analysis individually for customer satisfaction and customer loyalty. Then step 2, I will perform measurement model of the study, including both customer loyalty as well as customer satisfaction. Then step 3, we need to measure the hypothesis. Here we need to measure either customer satisfaction is making the positive impact towards the customer loyalty. Clear? So let me perform CFA first. So how to select the variable? Keep your cursor top of the CS1, customer satisfaction, item 1, then press Shift, then Control, then down arrow up to CS3. Okay. Then after selecting the items, just drag, then leave it to the left side. Then you will get the small comment box, then press enter. Then press enter. Okay, automatically you will get the model. Okay, customer satisfaction, our construct. Under customer satisfaction, we have 3 items. One is CS1, CS2, CS3. Customer satisfaction 1, customer satisfaction 2, customer satisfaction 3. Okay, even if you want to change the color also, you can change. If you want to change the indicator also you can change, like top, bottom, left side or right side also you can change. Even, sir, I want to target some higher ended journals. Normally, higher ended journals like A and A star, if you are sending color pictures, maybe after the revision, after the acceptance, they will ask you to convert into black and white. Okay, so just select, then under the coloring you will have two menus. One is blue color menu, then black color menu. Click the black color menu, it will become black and white. Okay, just select from CS1 to CS3, then drag and put it in the right side. Then select Control A, select all the shapes, then change the color. Or else if you want to keep blue or yellow color, if you are writing thesis, keep it that as a different color. Or else if you are targeting any higher ended journals, please make it as black and white. Okay, because some journals, maybe after the review process, they may ask you to convert into black and white. Okay. So after this, go to calculate. Again, I repeat, go to calculate basic CB SEM algorithm. Basic CB SEM algorithm. Again, I repeat, go to calculate basic CB SEM algorithm. Then calculate, start calculation. Start calculation. Okay. So normally, whenever you are performing CB SEM, you should consider standardized coefficients. You should not consider unstandardized coefficients. Even whenever we are performing regression, whether it is a multiple regression or stepwise regression, we used to consider standardized coefficients. Likewise, CB SEM also kind of linear model. So we supposed to consider only standardized coefficients. Okay. So here, go to outer model, then click the drop down menu. Again, I repeat, whenever you are performing CB SEM or PLSM, you should consider only standardized coefficients. Then go to outer model, then click the drop down. Here you choose outer weights or loadings or standardized coefficients or standardized measures. Again, I repeat, go to outer model, then the last option, outer weight or loadings standardized. Okay. So after this, here one blue color button, that is open report. Click that one. Click that one, open report. Here open report, it's not coming. Here open. Yeah. Coming, You got already. Maybe left side you got all the menus. After clicking the open report, then you will get all the options in the left side. Path coefficients, total effects. Okay. Then indirect effect, outer loadings. Okay. Here in the CB SEM, we need to concentrate on 4 important things. So let me open my PPT. Are you able to see my screen? Now? Okay. Okay, let me share my screen. Okay, are you able to see my screen? I'm showing on PPT. Okay, so whenever you are performing CBSEM, you need to concentrate on certain things. One is, participants, don't worry, after completion of my session, I will share all my materials to the coordinator. They will post all the materials in your WhatsApp group. Okay. So first one is Cronbach alpha. Cronbach alpha should be greater than 0.7. Then again, composite reliability also should be greater than 0.7. Okay. Then AV, how to calculate AV, I will teach you everything. Okay, step by step, I will teach you. Even a smart PLS, everything automatically it will calculate. Even though it is calculating, we should have fundamental knowledge, or else it's very difficult to write the inference. I will teach you through Excel. I will teach you how to calculate composite reliability, AVE, okay, item reliability, sum of square, sum of errors. I'll come. Okay, so AVE should be greater than 0.5 or greater than 0.5. Okay, then discriminant validity. Discriminant validity should be lesser than square root of AVE. That also I will teach you. Okay, so then HTMT ratio should be less than 0.9. Then cross loading should be 0.5. Okay. So next is, some of the participants was asking some question related to model fit. Sir, CBSEM model fit is very, very powerful. There are so many measures are available like RMSCR, RMSCA, then GFI, AGFI. How to fix those measures? I found one beautiful paper. Okay, whenever I am writing inference for my papers, I am utilizing that paper as my base article. Okay, let me open that paper. Okay. So are you able to see my screen? Okay, it is there in the ResearchGate. Okay, you can download this paper from the Google Scholar. The name of the article is Structural Equation Modeling Guidelines for Determining the Model Fit. For each model fit, they have given the definition. At the last, they have given one table as appendix. There they mention what is the threshold limit for GFI. It should be greater than 0.95. Then AGFI also should be greater than 0.95. Don't worry, after completion of my session, I will share this paper in your WhatsApp group. Okay, so RMR, then SRMR should be less than 0.08. Then NFI value should be greater than 0.95. Then NNFI, that is TLI, should be greater than 0.95. Then very important measures like RMSEA. RMSEA should be lower than 0.06. SRMR should be lower than 0.09. Then finally CFI, chi-square fitness index, should be higher than 0.96. Okay, so these many measurement methods or model fits, we need to have the more perquisite measures whenever you are performing CBSEM. That's why majority of the people, instead of using CBSEM, they are preferring PLSM. PLSM, these measures are not required. Okay, so again I tell you, CBSEM, PLSM is very easy, whereas CBSEM is more powerful. Again I repeat, CBSEM is more powerful, whereas smart PLS is very easy. Okay, so let me teach you how to calculate AVE, composite reliability. Okay, are you able to see my screen? Okay.
Some of the participants, they are asking that you past mode, they could not
regarding model fit. Model fit.
From the beginning, can you, if you repeat?
Regarding model fit.
Model, not model fit, for this one.
Smart PLS, huh?
Smart PLS.
Okay.
You just take 5 minutes.
Okay. Again, I repeat one small recap. Okay.
You just inform them that.
Yeah. Again, I am giving the small recap. Okay. After installing the smart PLS, you will find 5 different interfaces. One is new project, PLSM, regression, process, CBSEM. I think today's session I will complete after 9 o'clock only, and we'll see. Okay. So we have 5 interfaces: new project, PLSM, regression, process model, then CBSM. Initially, you have to select new project. So let me give ABC as a folder name. Okay. Then create the folder. After creating the folder, left side of the screen under the workspace, you will get one folder icon. Under the folder icon, you will find 2 menus. One is import data file. Another one is create model. Initially, you have to select import data file, then navigate your data. Data in the sense which I have shared in your WhatsApp group. Okay. Then navigate the data. Here I will find the item list, then minimum and maximum. Since for my questionnaire, I have used 7-point Likert scale. That's why minimum is 1, maximum is 7. Then import. Then after that, you will get the second screen. Here, minimum, missing values. Then you will get mean, median, kurtosis, then skewness. Then after getting the screen, again click back button. Okay. So after that, automatically your data file name will activate in the workspace. Okay. Here my file name is basic model 1. Okay. Then after that, yes, participants, anybody having any doubt? Yes.
Fine, sir.
Okay, fine. Can I continue?
Yes, sir.
Okay, thank you. Okay, after that, go to create model. Go to create model. Then you will get the one small pop-up as new model. Here, my name of the project is ABC. Then model type. Here we are going to perform CBSM. Then model name. So I am giving model name as basic CBSM. Basic CBSM. Then click save. Then you will get one interface like MS Paint. Left side, you will find the list of indicators.
Okay.
Okay. So initially, I want to perform confirmatory factor analysis to test the measurement level between constructs and items. Then followed by step 2, we will perform SEM with CFA to measure the entire measurement model. Then step 3, we will check the structural model, that is inner model. Maybe we will analyze the hypothesis or maybe relationship between customer satisfaction and customer loyalty, or either customer
Fine.
satisfaction is making the impact over the customer loyalty. Okay.
Fine.
So under customer satisfaction, we have 3 indicators: CS1, CS2, and CS3. Keep your cursor on CS1, then press shift control, then down arrow, select CS items alone. Don't select the customer loyalty. Okay, CS1 to CS3, then again drag, then put it in the right side of your screen. Then you will get the one box. Inside the box, you will find CS, customer satisfaction. After getting this, press enter. Okay. So here you can do formatting, maybe left side, right side, top, bottom. If you want to change the color, you can change the color. Okay. Is as of now any doubt? Anybody having any difficulty?
No, sir. That has not come. What you have shown has not come. And
Okay. Yes. After drawing the model, go to calculate. Again, I repeat. After drawing the model, go to calculate. Basic. Choose basic CBSM algorithm. Basic covariance based structural equation modeling algorithm. Okay. Then don't change anything. Just click start calculation. Okay. Again, I repeat, structural equation modeling, it's a kind of linear model. Whenever we are performing linear model like multiple regression or stepwise regression or logistic regression or auto regression, we should consider only standardized measures. So go to outer model here, outer model, choose the third option, outer weights or loadings within the bracket standardized measures. After choosing this, click open report. Click open report. Click open report. Then after that, okay. So maybe participants might be using the updated versions. Maybe you will not find the menu, call it as open report. Directly you will find the options in the left side of your screen. Okay. Then in the measurement model, whenever we are performing confirmatory factor analysis, we need to concentrate on two things. One is model fit, number two, measurement model. In the measurement model, we have some adequate measures like Cronbach alpha should be greater than 0.7. Then composite reliability should be greater than 0.7. Then followed by AVE, average variance extracted, should be greater than 0.5. Then Farner-Locker, that is discriminant validity. Okay, maybe while writing the inference in detailed way, I will teach you what is Farner-Locker, what is HTMT ratio. Okay, Farner-Locker should be lesser than square root of AV, average variance extracted. Then HTMT should be lesser than 0.90. This is something related to measurement model. The next is model fit. For model fit, I have found one beautiful article in the Google Scholar. Whenever I am writing inference for my paper, I am utilizing this as a base article. Okay, so the name of the article is Structural Equation Modeling Guidelines for Determining the Model Fit. Okay, so after completion of my session, I will share this paper in your WhatsApp group. At the last, as appendix, they have given one table. There they explained about all the model fit measures like GFI, AGFI, RMR, SRMR, then RMSEA. Okay, I will share this paper. Yes, maybe after completion of my session. So you can keep this as a base article for writing your inference. Okay, so after completing this, go to outer loadings. Here in the left options, you will find some menu, that is outer loadings. In the outer loadings, again I am telling you, we need to concentrate only on standardized measures since it is a linear model. Okay, then select list standardized, list standardized, list standardized. Again I repeat, go to outer loadings, then select list standardized. Okay, so here CS1, CS2, CS3, those are items, whereas CS customer satisfaction is a construct. Okay, so CS1 loading is 0.691, CS2 0.799, CS3 0.860. Okay, the advised threshold limit for cross loading greater than 0.5. Some of the researchers, they are telling greater than 0.6. Okay, if you are following 0.6, please cite those articles in your research paper, or else if you are following 0.5, please cite those articles while writing your inference. Okay, so let me open one Excel file. Okay, how to calculate AVE. Okay, in the smart PLS, as I told you before, it's a very simple software. Automatically you can get AVE, composite reliability, then Cronbach alpha. But being a researcher, we should have the fundamental knowledge how the software is calculating AVE, how this software is generating composite reliability. Okay, so if you are clicking construct reliability and validity under quality criteria, if you are clicking construct reliability and validity, automatically Cronbach alpha and composite reliability, then AVE will come. But we should have the fundamental knowledge how the software is calculating composite reliability and average variance extracted. So let me open one Excel file. Okay. So estimates, which means our factor loading, estimates, factor loading. After estimates, we need to calculate item reliability. The formula for calculating item reliability equal to whole square of estimates. Okay, the whole square of factor loading, we used to call that as a item reliability. Okay, so followed by item reliability, we need to calculate delta. Delta means error. So how to calculate error? 1 minus item reliability. Again, I repeat, here estimate means factor loadings. Out of factor loading, we need to calculate item reliability. The formula for calculating item reliability, estimate whole square. Then followed by that, we need to calculate error. Error means delta. How to calculate error? 1 minus item reliability. Then we need to calculate AV, average variance extracted. Okay, AVE, average of item reliability. Average of item reliability. Let us discuss about the formula. Then I will give you hands-on training how to calculate AVE and composite reliability. Okay. Then next column, we need to calculate sum of estimate. Estimate means factor loading. Sum of estimate. Okay. Let's consider estimate as a x. Sum of estimate is then summation of x. Then sum of error, delta. Here we have calculated the error, which means sum of error as y. Here we need to calculate summation of y. Here, composite reliability. The formula for calculating composite reliability equal to sum of estimate into sum of estimate divided by sum of estimate into sum of estimate, finally plus sum of error. Okay. Again, I repeat how to calculate composite reliability into sum of estimate divided into sum of estimate plus sum of error. Okay. So let me copy the factor loadings. Again, I repeat, go to outer loadings, list. Under the list, you have to select standardized coefficient. Then here, copy to Excel, or else if you want to download the entire output as Excel file, you can click the above menu as Excel, you will get the entire output. Or else if you want to convert that into HTML page, you click the HTML page, it will automatically open in your browser. Okay, so here I am going to calculate only AVE and CR. I am copying this to my Excel. Okay, copying to the Excel. Then I am going to the Excel. Yes, maybe let me open the new screen or new sheet. Customer satisfaction, estimates, factor loadings of customer satisfaction. That here we are considering that as a estimate. Clear? Then I need to calculate item reliability. Formula for calculating item reliability equal to estimate whole square. Select estimate whole square, press cap. In the numbers, top of the 6, you will find a cap menu, shift 6. Press shift 6. Cap. Then here square. Then put 2. Okay. Estimate equal to estimate cap 2. Cap means square root of 2. Again, I repeat, estimate we have taken from the list of standardized, then copy here, then paste it here, paste it in the estimates. Okay. Then equal to select estimate. Then how to insert this cap menu, shift, then press 6, number 6. Okay. Then type 2 because estimate whole square. Whole cube in the sense instead of 2, you should type 3. Okay. Then enter. Then enter. You will get the estimate whole square. Then drag down. Okay. Then item reliability. Next is we need to calculate error. Okay. I will share this Excel file. Okay. For your understanding only, I am teaching how to calculate AVE and composite reliability because Smart PLS itself, we are getting AVE and composite reliability. Whereas we should have fundamental knowledge how we are calculating AVE and composite reliability. Okay. So error delta equal to 1 minus item reliability. Again, I repeat, how to calculate error delta equal to 1 minus item reliability. Then click enter. Then you will get the item reliability. Okay. So next is average variance extracted. Average variance extracted. Formula average of item reliability equal to average select then item reliability. Item reliability which is there in the second column. Okay. Third column error. First column estimate. Select item reliability which is there in the second column. Then close bracket. Then click. Then you will get the AVE. What is the minimum threshold for AVE? AVE should be greater than 0.5. Here arrived AVE is 0.618, which means greater than 0.5. Clear? Clear? Okay. Then sum of estimate. Sum of estimate equal to sum sum open bracket sum of estimates which is there in the first column factor loading which we have taken from the smart PLS output. Then select equal to sum. Then followed by we need to calculate sum of error equal to sum. Then open bracket select the error delta. Okay, error delta. Then close the bracket. Then enter. Then we got sum of error. Then finally, very important measure, composite reliability. Okay, so equal to open bracket sum of estimate into again sum of estimate close bracket then divided by double brackets sum of estimate into sum of estimate then close the bracket then plus again sum of error delta. Okay, as per my Excel sheet, H6 is sum of estimate, I6 is sum of error delta. So H6 into H6 divided by H6 into H6 plus I6. I6 sum of error delta. Then close bracket, enter. Then we got 0.8. Composite reliability should be greater than 0.7. Okay, this is how we need to calculate AVE and composite reliability. Even smart PLS software also calculating AVE and composite reliability based on this formula. Okay. Yeah, I'll share this Excel sheet. I'll share. Okay. I will share the entire folder in your WhatsApp group. Okay. So now can we discuss how to write inference for each table? Okay. Okay. So this is how you need to write inference for each table. Okay. Measurement model for customer satisfaction. Measurement model for customer satisfaction. Okay. So I am going to the smart PLS. Then I am choosing model fit. Okay. So after calculating the factor loadings, okay, even directly you can keep the composite reliability and validity table, or else you can calculate in the Excel. Okay, then copy the table from the Excel sheet. Maybe let me copy from the Excel sheet. I'm just copying this table. Then open the Word file. As table 1, you keep the model fit. Okay. The table name is something related to customer satisfaction. Okay. Okay. Under that, I am giving the source since the data is collected from the primary source. Okay. So the individual reliability of the items is evaluated using the factor loadings. The factor loadings above 0.5. So all the factor loadings, that is estimates 0.5 is acceptance. In the above table, all the factor loadings are above the recommended value. It shows that the statement are related to the construct. Statement in the sense 3 items, CS1, CS2 and CS3. All those 3 items are closely related with the construct, that is called as customer satisfaction. Then the internal consistency of all the items is ensured through the construct validity, which evaluates the rigorous with which the latent items is measured as observable items. The AVE value should not be less than 0.5 or should be greater than 0.5 to ensure the conversion validity of the model. Okay, so both conversion validity and construct reliability are having the perquisite value more than the standard value measures. Okay, or maybe more than the accepted region. Okay, so after that, again I need to keep the measurement model diagram here. Okay, measurement model for customer satisfaction. So I am going to the smart PLS. Okay, then right click. Okay, right click, export as image. Okay, export as image or maybe clipboard. Okay, again I repeat how to copy this diagram. Right click, export as image. Then instead of choosing external file, if you are choosing external file, automatically it will store in your computer, or you may copy and paste. If you want to copy, click the clipboard, then export. Then go to your Word file, then paste the model. Okay. So again, here we are writing measurement model for, here our latent variable is customer satisfaction. Correct. Customer measurement model for customer satisfaction is shown in the figure 1. The construct reliability should be above 0.6. Ours is 0.8, which means greater than 0.6. Okay. And the measurement model table portrays that the construct reliability values respect of all the items exceeds the minimum requisite value. Hence, all the measurable items command the desirable construct reliability, which means all the items like customer satisfaction 1, CS2 and CS3, those items are contributing towards the development of customer satisfaction. Okay. So then next is, likewise, we need to perform confirmatory factor analysis for customer loyalty. Okay. Again, I am going to the smart PLS. Okay, back. Then if you want to save the file also, you can save. You can make the duplicate also. Okay. So again I repeat, after importing the data, basic CBSIM. Here, initially we performed confirmatory factor analysis for customer satisfaction. Next is customer loyalty. Under customer loyalty, we have 5 items. Okay, just select the first item, then shift control down arrow, then select till CL5, then drag, then leave it here. Okay, so then again go to calculate, basic CBSIM algorithm, start calculation. Then write inference for AVE, composite reliability, then copy the picture from the smart PLS, then paste it in your document, then write the inference for composite reliability. Okay, so individually you need to calculate CFA for each construct. For example, I might have 9 construct or maybe 10 construct in my PhD thesis. Yes, for those 10 constructs, you need to perform CFA individually. Sir, whereas I am writing research article, my model has more than 12 constructs. So if I am keeping all the models, maybe length of my paper will become nearly 60 or 90 pages. If you are writing manuscript, CFA is not required. There straight away you can keep SEM with CFA and SEM. Okay, if it is a manuscript, if it is a research paper, please keep only structural SEM with CFA, structural equation modeling with confirmatory factor analysis and structural equation modeling. If you are writing thesis, please keep confirmatory factor analysis also. CFA you should keep in the methodology part, because here only we are fixing the items with the constructs. If any of the construct is having lower factor loading, less than 0.5, in that circumstances, we need to remove that item from your model. Okay. So
Excuse
this
me,
is how
sir.
we need to, yeah.
Sir, you said that we have to do this CFA individually. Is it because it's in PLS? Because I think in AMOS we are
Excuse
doing
me,
it
sir.
all
Can I
Please,
ask a
together.
please.
question?
Yeah, please speak a little louder.
Can you hear me now?
Yeah.
Actually, you said we have to remove if the value is less than 0.5, no? So should we mention that we got a value less than 0.5? That's why we
Yeah.
removed the
In the
methodology.
manuscript, 100% we should mention, madam. I'll show you
We should
some of my,
mention.
some of my article. Wait, let me show. Very good question. Wait. Let me open my paper. Okay. So, okay. As I told you before, this is a paper which I published in the ABDCB category. Okay. So, see in the results parts. Okay, I'll show you. Okay. So some of the items we have removed from the model that we have mentioned in our paper. So 1 minute, let me. Yeah, 1 minute. Because now whatever items we are keeping, maybe I am having 150 items in my model. So all 150 items are accepted. Reviewers also, they will think, no, madam. So whatever you are removing, you need to address in your manuscript. See here in the paper also we have addressed. So I am just opening that part. Yeah, 1 minute. Here, see here, 8 items under word of mouth. Item number 4, medical practitioner sensitivity, 5th item. Then perceived norms, 5th item. Likewise under ES, 6th item. MPS, 7th item. We have removed here, had to be removed due to lower loadings and cross factor loadings. I hope you got answer for your question.
Yes,
Yeah,
sir.
yeah.
Yes, sir. Thank you. Thank you.
Yeah, thank you. Then one more paper also I will show you. This is my latest article, which is published under ABDCA category, Scopus Q1. Okay. So this is also something related to service quality. Okay. So we have measured the service quality of medical applications. Also, we included 2 local variables. One is patient sensitivity, another one is patient experience. This is my latest article, ABDCA category and Scopus Q1. Okay. So here also some of the variables are eliminated due to lesser loadings. Okay. Yes. Any other questions from the participants? I will share all my paper after completion of my session. Okay. Yes, participants. Can we process some with CFA? Okay. Thank you.
Sir, I think Hannah has asked some question.
Yeah, in the WhatsApp.
In
Huh?
chat.
Yeah, let me check, madam. Google share, we will download.
Chat box.
Chat box. Huh? Why do we have to do CFA for each construct separately? I think in Amos we do it together. Yeah. Same with CFA you can perform. As I told you before, if you are writing manuscript, straight away you can perform same with CFA. Whereas thesis individually better you can perform. Then finally you show the same with CFA. Then finally structural equation modeling. Again I repeat, madam, for individual measurement you can keep it for your thesis. If you are writing manuscript, straight away you can keep same with CFA. Because lots of beginners are attending this program. If straight away I am teaching some with CFA, they will get some sort of confusion. I hope, Hanna, you got your... Yes? Okay, thank you. Okay, let me go to Smart PLS. Now we are going to perform same with CFA. Okay, same data. Create model, basic C. Okay, so here in the right side we have CS1, CS3, then CL1, CL5. Then select CS1 first till CS3, customer satisfaction items. Then drag down and put it here. Okay, so then you move a little down, then you rotate. Okay, or if you want to keep like this also, you can keep top or bottom. Okay, then again customer loyalty. Under customer loyalty we have 5 items. Yes, again same way you select, then move to left side. Then very important thing is under CS we have 3 items. Those items only you should put under the CS. You should not take CL1 or CL2, should not include under customer satisfaction. Okay, so I am keeping both the constructs. One is customer satisfaction, another one is customer loyalty. Here we are measuring CBSEM, covariance based structural equation modeling. Now I need to create covariance. How to create covariance? At the top, go to connect, then from CS to CL, then you will get the covariance. From CS to CL, then you will get the covariance. Okay, again I repeat. Okay, after putting both the diagrams, select connect or correlation, select correlation from CS to CL, customer satisfaction to customer loyalty. Or else if you want to rotate the picture also, you can rotate. So let me rotate like this. It seems to be like paint only. Okay. Okay, you can rotate like this, or left side, right side. Okay. Covariance. After this, go to calculate, same like CFA, basic CBSEM algorithm. Okay. Then in the report, then you check. Then instead of outer loading weights, we need to choose standardized measures. Then go to construct reliability. Okay, construct reliability. Copy. Then let me open the inference document for entire measurement model of the study. Okay, entire measurement model of the study. Then write the introduction about the your study. Then copy the table of composite reliability, then AVE, paste it here. Then copy your model. Copy your model as clipboard. then paste it here. Okay, then write the inference. Then at the time of performing SIM with CFA, we need to consider one more measure, that is discriminant validity. Discriminant validity. So how to take discriminant measures? Go to open the report. Then under the construct reliability and validity, choose discriminant validity. Again, I repeat, under construct reliability and validity, select discriminant validity. Then choose Farnan locker, F&L criterion. Okay, this table you need to copy. You check whether you have draw the model appropriately or not. You check.
Figures shouldn't make any difference.
Same data you're using.
Yes.
Okay, so similar way, we need to copy the figure, sorry, discriminant validity. Okay, so discriminant validity, open report, then under construct reliability and validity, we supposed to choose discriminant validity. Here, Farnan locker criterion. Then here you just copy to Excel. Then open the Excel file, paste it here. Then make that as all border. Then again copy. Go to your Word file. Then keep the discriminant validity. Okay. Again I repeat, discriminant validity should be lesser than the square root of average variance extracted. Here in the note, I have written diagonal elements. Diagonal elements are the average square root of average variance extracted. Of diagonal elements are square correlation among the constructs. Okay, these diagonal elements 0.877, 0.851. Okay, then of diagonal elements 0.346. Of diagonal elements should be lesser than the diagonal elements, which is we got 0.346. It is lesser than 0.87, also lesser than 0.51, which means my measurement model is clearing or passing the discriminant validity. Okay, through CFA, SIM with CFA, we measured construct validity, content validity, criterion validity, finally discriminant validity. Okay, so now there is no problem with my construct as well as with my item. Okay, so finally I need to check my hypothesis. Okay, here my hypothesis is positive impact between customer satisfaction and customer loyalty, or customer satisfaction as making the positive effect on customer loyalty. Okay, so next is structural equation modeling. Next is final one is structural equation modeling. Then go to smart PLS. Okay, the same. Yes, remove the covariance, or you can make the duplicate file as, sir, I want to save my model in my repository. So you can make this as a duplicate. Again, you draw the model. Okay. So customer satisfaction, then customer loyalty. So let me align like this. Okay. Customer satisfaction and customer loyalty. CFA performed, SIM with CFA also completed. Then final one is SIM. Here we are going to measure our hypothesis. That is our inner model. Relationship between customer satisfaction and customer loyalty. Okay. So instead of connection in the SIM with CFA, we have connected using the covariance. Whereas here we are measuring the path. Okay. So go to connect. Here my independent variable is customer satisfaction. Then dependent variable is customer loyalty. From customer satisfaction to customer loyalty, you connect. Okay, this is called it as structural equation modeling. Then after the connection, you will get the factor loading. Then again open report. Here we need to see the path coefficient. Click the path coefficient. Path coefficient parameter estimates, that is beta. Beta should be greater than 0.2. For our model, beta is 0.4, which is greater than 0.2. Then t value, if it is a two-tailed test, t value should be greater than 1.96. Whereas our t value is 10.491, which is greater than 1.96. Obviously, if t value is greater than 1.96, p value lesser than 0.05, which is 5 divided by 100, which is 5%, 5 divided by 100, 0.05. Here my p value is 0.000, okay, which means lesser than 0.05, which means I need to write the inference as alternative hypothesis is accepted. Hence, there is a relationship or there is an impact of customer satisfaction towards customer loyalty. Okay, so let me open the inference. There I will teach you how to write inference for the structural equation modeling. SEM analysis. My independent variable is customer satisfaction. My dependent variable is customer loyalty. My beta value 0.403, t statistics 10.431, and p value 0.000. Then H1 seeks to assess whether IV, here independent variable is customer satisfaction. Employ significant impact on dependent variable customer loyalty. The result of the hypothesis is test revealed that maybe I'll put customer satisfaction as CS in the first line, then customer loyalty as CL. Then instead of writing the entire variable name, I'll keep only short forms: customer satisfaction, customer loyalty. My beta 0.403, p value 10.431, p value obviously lesser than 0.01. Okay, this shows that in the context of present paper, IV customer satisfaction would result in customer loyalty. Hence, hypothesis H1 was validated. Okay, so maybe if you are having too many variables in your model, okay, you can perform. Okay, since today we are starting from the introductory part, maybe tomorrow again I'll teach something related to one dependent variable with 3 independent variables. Then I will include some moderations, then mediation analysis for categorical variables using MGA, multi-group analysis. Tomorrow during my session, we will see. Okay, if time permits, I will teach you higher order constructs and second order construct. I don't know, but I will teach up to multi-group analysis. If time permits, we'll see higher order construct and second order constructs. Okay, that's it from my side.
Okay, sir. Thank you. Is there any question? You please ask. Our expert is ready to reply.
Yes, sir, regarding all my materials, I will post in your WhatsApp group.
Can we approach you in case we get stuck anywhere with our analysis?
Yeah, sure. My number also there in the WhatsApp group.
Because we will sit in TT, we will come to the last building, I think, at the end of the
My number is there in the group. Or if you have any doubt, please, anytime you can ask.
Not doubt, sir. Like, at the time of doing itself, we might get stuck actually.
Yeah. Fine.
Because it's tough to remember so many things, and it's just a practice, I believe. Because
Sure,
unless we
ma'am,
practice
sure, ma'am.
regularly.
Thank you so much.
Yeah. Thank you so much. Yeah.
Sure.
I will be sharing the
Thank you,
recorded
sir.
video maybe tomorrow or day after tomorrow. So you
Thank
can
you,
see
Jasim, sir.
Okay,
So,
and
Jasim sir, we
feedback.
can add your name in the paper also then.
Yeah. Fine. We'll do some collaborative.
Sure. Thank you so much.
Sure.
Feedback link will be shared tomorrow. Sir is also having tomorrow session, so we will share tomorrow.
Okay. Anything else?
Yes.
Mohsin, can I do?
Yes, Dilip, please.
Yeah. Thank
Thank you all.
you. Tomorrow again we'll meet. Okay. Thank you.